Hello everyone, this is RENIC and welcome to our channel. Today, Dr. Gan has taught me the knowledge about the working principle of piezoelectricity and triple electricity. I'd like to say it's quite funny, but challengeable at the same time. That's the reason why I'm smoking here to relax myself. You don't believe that? Let's see it.
Your research area consists of piezoelectric nanogenerator and a triboelectric nanogenerator. So
Yes.
could you please briefly talk about their difference?
The significant difference in terms of the working principle is that triboelectric is actually induced from the charge separation of opposite material, or based on two principles. First, contact electrification, and second, electrostatic induction. So this material itself, it doesn't require intrinsic polarization. So you just have to need two materials in contact in opposite charge, then you induce the kind of charge based on the contact separation. So you don't have to have specific asymmetric crystal compared to piezoelectric material. Though these two materials are in two different working mechanisms, but they share common features by harvesting the energy using vibration formation of the material. Both actually quite ideal for actually low frequency working mechanism, I would say.
The triboelectric effect has been discovered hundreds of years ago. So why such effect had not been applied for electricity generation until recent years?
Why during that time has not been actually utilized for this kind of energy? Probably due to the equipment or the limitation of the knowledge during that time. There are actually two criteria to take note here. In general, science define triboelectrification as a charge generation due to rubbing material. You have to do rubbing.
Yeah.
So secondly, in the tank, more specific scientific term, tank is for contact electrification, where two opposite charge material in contact, then charge being generation without rubbing. So this is the main difference. So we only induce charge upon physical contact without rubbing. So when you do rubbing, normally we will refer to electrification to material. So that is how you get the charge, especially in winter. So when you walk around using a rubber shoes, the electron losing from your body, and then you get electrical shock. So this is kind of TE phenomena. But in contact electrification, different. So without rubbing the material, just a physical contact of two material, okay, then charge distributed. For example, the trouble positive charge, you lose electron, redistribute at the surface layer. So negative charge will tend to flow to the actually trouble negative material itself through electrostatic induction phenomena, and hence a current will flow in the device. So this is the difference.
Okay, for next question, and last time we have asked Dr. Braden about the application of supercapacitor in electric cars, but he said the energy density of the supercapacitor is low. Yeah, which is not suitable for the electric cars. But is it possible for us to design an energy recovery system to combine the TNG or PNG with the supercapacitor to harvest the energy produced in the friction process during the driving?
I have to say that it's not practical to harvest large volume of energy using tank or supercapacitor, or store large volume of energy using supercapacitor, because supercapacitor and battery has different advantage by its own. So, and also two different significant working mechanism. For supercapacitor, it's mainly actually dealing with the surface charge storage. That's why the feature or advantage against the battery, the charging rate. So you can charge and release charge in a shorter time compared to battery. So back to your question, yes, it's possible. That's why currently I'm working with Dr. Braden. So try to form an electric double layer using a PVA-based ionic material. So we try to generate electricity using this PVA-based material. And then on his part, for the supercapacitor, he used PVA to dock with a different kind of nanomaterial, for example, like nano silver, nano gold particle, and probably nanostructure of graphene. Okay, different various type, and then for storing charge purpose. And previously mentioned, like for tank, it's kind of twice energy, because the energy volume harvesting from tank or tank is so small. So it's compared to the wind energy, nuclear energy. And why we should focus on this area? The reason is very simple. So in the era of Internet of Things and sensor network distribution, so you should carry large volume of energy package along with you, right? Okay.
Yeah.
So you see our cell phone electronic gadget, the size of the gadget itself has shrunk. significantly if you compare to 10 years ago. So it's very, very much different now. And also the battery is a long-lasting battery compared to 10 years ago, right? Thanks to the actually lithium-ion battery development. So I think this portable electronic has drive the development of tank and bank nano generator, simply because that we are not aiming to distribute energy compared to those conventional or renewable energy like solar, wind, and nuclear energy. But we are aiming for those small portable devices. For example, so there are 4 important points for development of tank. First, we are aiming for micro and nano power source for actually portable devices, for example, or wearable, flexible electronic, and this mobile electronic wire power management unit. And a significant advantage over others for the tank is that the energy conversion efficiency. So it has reached around 50 to 85%, depending on the working mode itself. Second, we wanted to work it as a self-power sensing unit. There are trillion sensors being distributed all around in the world. So these sensors require a battery to power. So if, let's say, if I focus in Malaysia itself, so if I have million sensors being distributed in West Malaysia itself, so let's say battery lifespan, your supplier may promise you that within 3 to 5 years, you don't have to replace the battery. So we only have to have to do maintenance every 3 years or 5 years. But you have to consider that you have millions of sensors distributed. So you have to replace millions pieces of battery on it. So why not we just actually replace it with carbohydrate nano generator, which can instantaneously supply charge to you wherever there is vibration or deformation on the material itself. This is one of it. Third point is that carbohydrate can generate very high voltage but low current. So it can use as a high voltage supply source. It's also been proved by actually Georgia Tech Group by Prof. Wang, and can actually generate plasma source. And finally, I think this is what very important in China, Asia Pacific. This nano generator is used or fully utilized for harvesting water wave energy towards the blue energy dream. I think this is a very significant implication in the research field. And as you always claim, the energy volume is very small, but the advantage using tank is that I can distribute millions of single cells to make power grid and harvesting water wave energy because outstanding output efficiency at low frequency. This is one of the important features of the tank and compared to the conventional electromagnetic generator. So far, the Research Institute, they have proved that energy harvesting efficiency for this blue wave energy has reached 28%. So I think this is quite a significant achievement compared to others. Do you have a smartphone, smartwatch with you? How frequent you have to recharge your smartwatch? Yeah, every single or every 2 days you have to charge one time, right? So if we able to increase the energy density being produced in a trouble generator, because we have pulse, right? So blood is circulating in our body. So with pulse generated, the vibration with the pulse, so this sustainably power up the electronic gadget or wearable devices in the future. Actually, researchers are working hard towards this direction. I think it can be realized in next 10 years.
Such, we call it the self-power system, driven by TNG or PNG, very bright future. In the future, self-drive system will be the sensor or will be the energy generation system. Which one have the brighter future?
I would say actually both are very important. Blooming of era of IoT and sensor networks can serve this purpose perfect. But according to the recent article published by Peking Research University under the Academic Significance of Science China, they have developed as a pacemaker for those who have heart disease. So when you implant pacemaker in your heart, actually you require a battery. So every time you take out to replace the battery, there is some risk. So they have used this pulse generation actually to power up by tank. Successfully demonstrated the idea. I think this is one of the great idea being demonstrated for medication line. So both are important. For we have to actually diversify our direction for this. For main reason, I think human is going to face difficulty. So on food, energy, and also I think probably the medical health criteria. So this will be our future direction.
Yeah.
3 important aspects. So we should move towards to this research direction in order to solve the human being problem, as also with booming human population up to 7 billion for now, and we are reaching actually 8 billion soon.
So with such technology, we have a bright future.
Yeah, yeah.